All right, yeah, welcome back. So as we proceed from where we stopped, the next thing we want to do is to perform what is called PCA. Usually, after the postcode superimposition or GPA, we want to perform your PCA, which is very important because PCA will give you three results. Will give you the shape, the score, and the graph. Okay, so we're going to look at the three later, but PCA means principal component analysis. Is one of the most widely used methods for exploratory multivariate analysis. Very common to morphometrics actually, though it's used also in other area of fields or subjects. It can be used to display the major features of a shape or shape variation in a data set, and also as an ordination method to discover patterns in the relation among observations. Okay, now the PCA of the process coordinate or our result is always referred to as relative WAP analysis. If you remember, we saw that last time in was it not in the past? Okay, if you remember then. So this is without weighing for bending energy and including the uniform components of shape variation, right? The PCA is based on special decomposition of a covariant matrix mathematically, all right? Yes, it intimately tied to covariant matrix, all right? That is a MorphoJ. So the nature of covariant matrices can vary from, for example, can be derived from the symmetric or asymmetric components of shape variation. That is sometimes, or it can also be a genetic or phenotypic kind of variation. Okay, so we have before we go into PCA actually, I want you to first understand that in this arrangement, if you see that we have 4 tabs here, the first tab will be showing you what is going on. If the last option or operation we performed last time was postcode fit, so it will show you if it's successful or not. You can see the result here, successful and result added to the data set. So that one was performed. That the report we give you a report of what is going on. Then the graphic is the one that we already saw with our charts or graph. Then the result is the data result of what you have performed so far. You can see it telling you here that we first look for outliers, okay, which we found none. Then here we look at we perform postcode fits, and it gives us of valid data set, okay. It gives us we have already, okay, we know we have the 2 landmarks in 2 dimensions. Don't forget, I didn't explain the landmark issue because I've explained that before during my previous this thing, so that's why I didn't bother about that. You can go and check that. So the data set contains 120 observations, 60, male 60, female 60, of which are included in the analysis. The average shape is what we are looking at now, which we just perform, called mean shape. That is what our postcode fit gave us. Okay, you can see landmark to landmark. This is the mean shape of that. All right. So this is a postcode sum of squares and the tangents. So this is just what we have for now. So you'll be coming here once in a while to see the output or see the result of your operation here as we continue. So now we want to go back now to the budget tree. You have to select your usual database you are using, must be selected by default. The first one is select actually. So we want to perform what is called PCA. Before PCA can be performed on any database, you must first perform what they call covariant matrix. Covariant matrix. So if you click on the preliminary here, before covariant matrix, let me just show you quickly before you go to that how to exclude or include observations. Maybe you have observation you want to exclude or include from your database. Because the observation we have female, male, female, or you can see their names here. So you can, anyone you want to exclude, you can exclude here or include here. So you can even create a data set from there and say, okay, create a data set from it and make a new data set to add it here after you have exclude or include. So anyone you want to exclude, just put add it to this place to be here and accept to be excluded from the data set. Maybe any observation that is not, you don't want to be included in the analysis, you can exclude from here. Okay. Having said that, let's go back and now perform our our PCA now. Now we have to first generate what we call covariance matrix first on the data set. Without that, you cannot perform PCA. Actually, we are supposed to come here and just select this and click on prediction, then PCA, but to give you error because you can see error here saying that the selection contains no covariance matrix. Please generate a new covariance matrix. So for every PCA you are performing in MorphoJ, you must have a covariance matrix. You can have as many as possible actually, but because as you perform, but one will be by default. One will be default one you're working with per time. So let's click on preliminary and say, okay, generate covariance matrix. So it asks you, you are generating based on the database, and also we are performing what they call cross coordinates together with it. So here, you just click on execute here. That's all. You click on this. That's all. By default, this will be selected. You just click on this data set you are using. But by default, data set don't need to be selected because it's already one here. But because we are having two, that's why you need to select it here. So you are selecting this one because you are using this. So click on execute here. So you can see it's generated. You can see this is our postcode fit now. I mean our covariance matrix now on this postcode coordinates we have generated now. So you have to select it now. So if I click on this guy now and say perform covariance matrix now to perform, all right, here is it now. Okay, so now because we have prophecy, so because we have only one postcode field, that's why it does that. So if I have more than one, okay, I have to select it too. I have to click on this to do that. But I have one, so automatically by default you recognize that under the database there's only one postcode, one covariance matrix there, so it just pick it up automatically by itself. All right, so now we have done that now. So we can now go to, if in the graph you can see the postcode fit here. Let me just put that here. So this is our shape variation, and this is our shape. So this one is showing you shape variation automatically. Now you can see that we have actually three tabs or sub tabs under the tabs here, under the graphic tabs. We have three sub tabs here, right? So this is the first one we did before, that is our GPA. So this is our PCA now. Okay, take note of that. So as you are working, they will be lining up here, okay, one by one. All right. So if you look at it, we have three stuff here. We have a PC shape changes here. This is this first one. Okay, you can see the shape changes of the PCA. You can see here. You can see here. So this this diagram is only the shape changes associated with the pieces, what they call eigenvectors. All right. This graph is only produced if the covariance matrix is for data that can be represented as shape changes. Okay, we have that's a scale factor actually, but I will explain further about that later because you can see that they are not the same. It means the shape of the nose, can you see the shape of the cheek, or both the left and right. Okay, the shape of the lip, the eyebrow, you can see here. So you can see the shape, our shape is changing. Okay, orthogonally. So you can see here. So that will be explained later. But let's just understand that we have our this one is very important. You're going to include this one maybe in your manuscript or your your thesis as you work on. We have eigen values as well. This one eigen values, you can see here. Some of you be familiar with this particular one here. We have that also in our past, if you remember very well. Okay, so you can see this showing you this one is also percentage of the total variance of which for which the PC accounts. So essentially how many PC that account for number of number of operation, you can see it here. So you can see, so we have total number of PC percentage accounts. So this is for each principal component. So we have 60 here, you can see pieces. All right, so we have what they call also PC score. Okay, PC score is the scatter plot of the PC scores. Okay, sometimes if there's only one dimension, it gives you histogram. Okay, to give you histogram. All right, so the graph is only produced if the covariance matrix on which the PCA is a base is derived from a data set directly. Okay, from data set. So you can easily increase the size. Right click on it like this and say resize point is 5.0 now. I can just say enter 8 and press enter. So it become bigger. So I can see it in a bigger dimension or bigger size, so that you can be able to see. So when you're done with this, you can just right click on this and say export graph. You can say export. All right. So you choose here. You have SVG here. Okay. That is your normal scale effector graphics. But you can just open there and see use PNG, BMP, JPEG, or GIF. So I always prefer to use PNG sometimes, most times. So I just generate my PNG out. Okay, I can just choose where I want to save it. I save it there, and if I'm done, I can just so this is how you export it out. All right. Same thing with this. You can also right click and do the same thing. Export out your graph, maybe in PNG. Export it out to your profile. So just click on export until you export it out. All right. So if you are done, you can open it in a graphic environment and crop out unnecessary space outside. Maybe this one you don't want it there, you can crop it out so that you can have only the shape remain. Okay. All right. So this is what you have for now. But why this one is done? Yeah, you have to go to your result now to go and see your result, because you have PCA result automatically now. So you can see what I'm talking about here. You can see here. So when you see from here that we started, this is what we stopped before. Stopped here before last time, if you remember. Now he has done PCA, okay, of covariance matrix of disposed coordinates. Now he has done it. So he has done it based on this particular our 60 observations. Okay, you can see here. So now we have eigenvalues and variance, the cumulative numbers. Okay, so you can see the variance here. Okay, as variance. So this percentage cumulative variance. So to be total 100. Okay, variance is coming down and total is 100. So you can see how it is. So now the PCA itself is here. You can see the PCA here. You can see PC1, PC2, PC3. You can, if you go down like this, you can see total pieces here. We have 60 pieces in total. You can see for the 120 observation, we have 60 pieces. All right. So you can see. You can actually copy this PC out. You can copy it out like this. Okay. If you want to use it in Excel, for example, you can copy it out and paste it in Excel. For example, I just come here, I open Excel, just open a sheet here, I just control here, I can paste. Can you see? I just paste, right? Nothing else. Okay, so I remove this line here. I don't want it. But I will explain further to you, because we don't actually use this PCA for the analysis. Okay, if you want to process your PC for maybe you want to use it later for statistical analysis, you want to use it later for machine learning as data set, you don't use this PC, because this PC is a dangerous kind of PC produced by MorphoJ. You use past PC. You can go, two of them work hand in hand. You can be using past together with MorphoJ together at the same time. What you do here, you can bring it here and continue. What you bring here, you can bring it and continue. So past PC is better, or you generating one from R. The PC from R and past, they don't deviate much from each other. They look alike. But the PC from MorphoJ is different, because it's not based on observations. That is the challenge of PC in MorphoJ. You can see it's based on coordinates. You can see S1, Y1, S2, Y2, S2. So it's not based on the observation. Okay, it's supposed to be observation 1, 2, things like that, but it's different in MorphoJ. It's just only based on your S and Y coordinate, which is wrong. So that's why we don't use a PC of MorphoJ for analysis. Okay, we only use the output of it, graphical output of it, to perform any kind of analysis you want to do. So we don't use the PC. All right. So the PC is not needed now for analysis, so because no observation attached to any PC here, you can see. So that is that for that. So take note of that as we continue. So this is our PCA here. So we are done with that. So we can just also go back to our graphic. So this is what we have. You have this, you have this, you have this. So this is so we stop there for today under this session. So when we come back again next time, we will continue from where we stop. Thanks so much for listening. I will see you on the next class.